Good evening, Ritu.
Good evening, sir, and happy Republic Day.
Thank you and wish you the same. So today you're having holiday.
Yeah, sir.
Okay, then good. So yesterday we are discussing about the structure of alcohols, phenols, na? Okay. In this one, we discuss the structure of alcohols. So first of all, to discuss the structure of alcohols means first we have to know the hybridization of the oxygen atom. So what is the hybridization of the oxygen in alcohols and phenols?
SP3, sir.
sp3 hybridization. Okay. And what is the bond angle, Maria? So what is the bond angle in alcohol? What is the bond angle in alcohol means here? 108 degrees and 5 minutes. So what is the bond angle in alcohol means here? 108 degrees, 5 minutes is the bond angle in alcohols. But phenols, so what is the bond angle means? Yesterday I had given 108, but actually it is exactly answer is here 109 degrees. Okay, so what is the bond angle in phenols? So this one is the phenol structure only, na? Okay, so this one is the phenol. In this one, oxygen is exhibited as a sp3 hybridization. And what is the bond angle in this one means here 109 degrees. Okay, and if you see the bond length between the carbon and oxygen in phenol is less than that of the bond length between the carbon and oxygen in alcohol. Okay, so why am I here? So here the bond length between the carbon and oxygen in phenols is less than that of the bond length between the carbon and oxygen in alcohols. So why it is less than means because of in phenols oxygen is it undergoes to the resonance. Whenever it undergoes to the resonance means automatically bond lengths are going to be changes here. Okay, so due to that and it forms as a partial double bond between the carbon and oxygen. In phenols, it forms as a double bond between the carbon and oxygen. Due to that reason only bond length is going to be decreased. Simple example, in alkanes and alkenes. So which one is having the greater the bond length? In alkanes and alkenes, which are having,
Alkenes, sir.
ma, Ritu?
Alkenes.
Alkanes are having greater the bond length. Okay, so which we can call as a alkanes means here carbon carbon single bond it is that means that we can call as a alkene. The bond length between the carbon and carbon means here 1.54 Armstrong units. In alkenes, the bond length is carbon carbon bond length is 1.34 Armstrong units. Okay. So if we compare with the alkene and alkene, which one is having the lesser the bond length means here alkene. Similarly, here also whenever it is forms as a partial double bond, the bond length is going to be decreases and bond energy is going to be increases. Okay, but alcohols and phenols are having which shape? What is the shape of the alcohols and phenols, ma? What is the shape of the alcohols and phenols, Ritu? What is the shape of the alcohols and phenols? The shape is here V shape or angular shape or bent shape we can call. Okay, the shape we have here V shape, angular shape or bent shape we are having. Okay, now so here let us see alcoholic wood. Now alcohols and phenols we'll see the difference, some differences. So what's the difference between the alcohols and phenols? So directly we can show the difference and we can see some examples also here. Okay, in alcohols here. Here, what is the simple example for the alcohols? Is any simple example for the alcohols? Ritu, what is the simple example of the alcohols?
Sir, could you repeat the question?
What is the simple example of alcohol? What is the simple example of
Sir,
alcohol?
ethanol or ethanol.
Methanol, CH3OH. So CH3OH is the one of the best example of the alcohol. Okay, and here phenols. So phenols is example means we can write as a on benzene ring if it is having OH group. It is having OH group. If the OH group is present on the benzene ring, that we can call as a phenol. Now only we had seen here. What is the structure and all. Now, if you see means in alcohols, OH group is attaches to the which hybridized carbon atom? What is the hybridization of the carbon which is attaches to the alcoholic group?
sp2.
Check it out. Methanol, CH3OH. What is the hybridization of the carbon in methanol? sp3. What is the hybridization means? sp3. It has a tetrahedral shape. OH, bond H, bond H, bond H. If the carbon is surrounded by the 4 sigma bonds means it exhibits as sp3 hybridization. If the carbon is surrounded by 4 hydrogen bonds means it exhibits as a sp3 hybridization. Okay. Now in phenols, the OH group is attached to the which carbon? Okay. What is the hybridization of the carbon which is attaches with the OH in phenol? So once again, I'm repeating the question. What is the hybridization of the carbon which is attaches to the OH group in a phenol? What is the hybridization of the carbon?
sp2, sir.
sp2, very good, ma. So what is the hybridization means here? sp2. Sir, how you are telling that sp2, Ritu? How you find out the given carbon is exhibited as
Three sigma bonds and 1 pi bond, sir.
3 sigma bonds and 1 pi bond. If it is having 3 sigma bonds and 1 pi bond means it exhibits as a sp2 hybridization. Okay, here all are, if the carbon is surrounded by the 4 sigma bonds means then it exhibits as a sp3 hybridization. Okay, if the carbon is surrounded by the 3 sigma bonds and 1 pi bond means it exhibits as a sp2 hybridization. Now we got the clarity. Okay, now one more example. Okay, so what are the examples of the alcohols which connected with sp3 hybridized carbon atom? Okay, in that also we have a saturated alcohol, aliphatic alcohols also it is there, and unsaturated alcohols also it is there. Sir, what are the examples of the unsaturated alcohols which contains the sp3 hybridized carbon atom means? So one is called as a allylic alcohol. Sir, what is with the allylic alcohol means? Last time I told that which we can call as allyl carbon. So which we can call as allyl carbon means then adjacent CH2 double bond CH bond CH2 OH. Okay, the carbon which is present adjacent to the double bond is called as a allylic carbon. This carbon is called as a allylic carbon. So what is the hybridization of the allylic carbon in allylic alcohol? Ritu, what is the hybridization of the carbon?
Sir, sp3.
sp3, very good, ma. sp3. Now one more example in benzylic alcohols. In benzylic alcohols, okay, or benzylic alcohol. What is the hybridization of the carbon in benzylic alcohol? In this one, what is the hybridization?
Sir, sp2.
This one, ma. Benzyl means this carbon. This carbon is called as
sp3,
benzyl carbon. After next to the benzene ring, whatever the carbon it is there, means that we can call as a benzyl carbon. Okay. Now, if the OH group is attached to the benzyl carbon atom, means that we can call as a benzyl alcohol or benzylic alcohol we can call. So, what is the hybridization of the benzylic alcohol? Carbon of the benzylic alcohol? What is the hybridization?
sp3.
sp3 hybridization. So in allylic alcohol also it contains the sp3 hybridization. Benzylic alcohol also it contains the sp3 hybridization. And one more example I'll write as here. So 2-phenyl ethanoic ethanol. 2-phenyl ethanol. IUPAC name is here. 2-phenyl ethanol. In this one, my question is, so what is the hybridization of the carbon which is connected with the OH group in this one? 2-phenyl ethanol. I didn't write the structure. You have to tell the answer. What is the hybridization of the carbon which is connected with the OH group in a 2-phenyl ethanol?
Sir, SP3.
sp3 ma. Okay. So what is the structure of the 2-phenyl ethanol means here? First I'm writing as a phenyl ring. Okay. That is only benzene ring. Bond. Ethanol. Eth means 2 carbon atoms it has to be there. CH2 bond. CH2 bond OH. Now what they're asking, what is the hybridization of the carbon? So which is attaches to the OH group in a 2-phenyl ethanol. So all these are the examples of sp3 hybridized alcohol. In all this one, OH group is attaches to the sp3 hybridized carbon. Okay, in all the structures, OH group is attached to the sp3 hybridized carbon atom. Okay, in that one, all these are we can call as aromatic alcohols. Okay, and this phenol also it comes as a aromatic alcohol, and phenol also we can call as a carbolic acid. So what is another name of that one means here? Carbolic acid. So phenol also we can call as a carbolic acid. So now you got the clarity, ma? Okay. Now, some other examples also it is there. The alcohols. Okay. So that means OH group is directly connected to the sp2 hybridized carbon atom. So what is the example for that one means here? For example, CH2 double bond CH bond OH. CH2 double bond CH bond OH. CH2 double bond CH bond OH. So generally we can call as a vinylic alcohol or vinyl alcohol. Okay, so that is also we can call as a vinyl alcohol. Vinyl alcohol. Vinyl alcohol. Okay. Now in vinyl alcohol, what is the hybridization of the carbon which is attaches with the OH? What is the hybridization of the carbon which is attaches with the OH mark?
Sir, SP2.
sp2. So this one is sp2. Okay. And one more question. So we have a orthocresol, metacresol, paracresol. 3 are there. Do you have any idea about the structure of the cresol, which we can call as a cresol? In orthocresol, what is the hybridization of the carbon which is connected with the OH group?
So could you draw the structure for once?
This we can call as an orthocresol. This we can call as a metacresol. Okay, this we can call as a metacresol, paracresol, OH bond CH3. This we can call as a paracresol. This we can call as a paracresol. So once you check it out, In all the cases, hybridization is sp2 hybridization only. In orthocresol also sp2 hybridization. In paracresol also it exhibits as sp2 hybridization. In metacresol also it exhibits sp2 hybridization. Sir, why it is exhibited as sp2 hybridization is OH group is directly attaches to the benzene ring. In benzene ring, what happened? We have a alternate double bonds and single bonds. So whenever we are having the alternate double bonds and single bonds means definitely it exhibits as sp2 hybridization only na. So in orthocresol, metacresol, paracresol, in all these cases, OH group is here. The carbon which is attaches with the OH group, it exhibits as a sp2 hybridization. Okay. Until here you got the clarity. And here one more important point I would like to discuss with you. Okay. So we are discussing about the nomenclature. Actually, we have a common names and IUPAC names sometimes. Okay, we have a common names and IUPAC names also it is there. So common names also we know and IUPAC names also we can wrote here. Okay, if the root word is containing one carbon atom is we can call as a propyl alcohol, methyl alcohol. If it is having two carbon atoms means that we can call as a ethyl alcohol. If it is having three carbon atoms means that we can call as a propyl alcohol. Four carbon atoms means butyl alcohol. So common names are we are writing as a suffix is with the alcohol. While writing the IUPAC name, based on the root word, by following the set of rules, we are going to write as a IUPAC names. In this one, what is the new concept we are having means here? Alcohols also we can call as a carbinol. Okay, so what we can call so alcohols also we can call as a carbinol. One new nomenclature system is that. So what is that one means here? Carbinol. Okay, so what is a new nomenclature system we are having means here? Carbinol system. Carbinol system. So we have a carbinol system. Sir, which we can call as a carbinol means what is the simplest carbinol? What is the simplest carbinol? So what is the simplest carbinol means? Methyl alcohol, methanol, CH3OH. CH3OH is called as a carbinol. What is the simplest carbinol ma? CH3OH. Sometime in NEET level also they ask the question. What is the molecular formula of the carbinol? Which we can call as a carbinol. Okay. So what is the molecular formula of the carbinol means here? CH3OH is called as a carbinol. Okay. How we can write as a nomenclature of the carbinol system? For example, here one structure it is there. What is the structure means here? CH3 bond, CH2 bond, OH. So what is the name of the compound in a carbinol system means here? Methyl carbinol. So what is the name of the compound my here? In a carbinol system means here, this we can call as a methyl carbinol. Okay, methyl carbinol. So how you are writing means here, methyl group, that is one hydrogen atom. In carbinol, one hydrogen atom is replaced by the methyl group. So that's why we can write as a methyl carbinol. Okay, and one more example. Here, if I wrote like this, CH3 taken twice, CH bond OH. So what is the name of the compound, Ritu? Ritu, what is the name of the compound? Ritu, are you getting my voice or not?
Yeah, sir, I'm just thinking to.
Okay. Then what is the answer? If you are having any doubt, me just to split the structure, then you will get the clarity. So how we can write this one means here. So the carbon CH group is attaches with the two methyl groups CH3 bond CH3, and this one is attaches with the OH. What is the name of the given compound? This we can call as a dimethyl carbinol. Dimethyl carbinol. Sir, how you are writing as a dimethyl carbinol means in carbinol, 2 hydrogen atoms are replaced by the 2 methyl groups. Okay, if 2 hydrogens are replaced by the 2 methyl group means that we can call as a dimethyl carbinol. Okay, and another one. So what is another one means here? Here CH3 bond, C bond, C2H5, CH bond, OH. So what is the name of the compound? What is the name of the compound? How many alkyl groups are attached to the carbinol? Ritu, how many alkyl groups are attached to the carbinol?
How many?
Alkyl groups are attached to the carbinol.
2, sir.
2. So can you tell me the name of the alkyl groups?
C2H5 and CH3.
What is the name of the C2H5?
I'm confused with the IUPAC names from the starting itself.
No, ma, I'm giving clarity. Let us see, you told that only one CH3 group. Okay, so do you have the idea about the root words? One carbon
Yeah,
atom,
sir.
meth. Okay, so 2 carbon atoms means eth. What about 3?
Prop. My prop is
Very
4.
4 ma,
Bute.
but 5,
Pen.
6,
Hex.
7,
Oct.
hept ma. 7 means hept. 8 means oct.
Oct.
9 means no. Okay. Now, my question is why I'm asking means here. You are telling that, so this carbinol is one side is attached with the CH3 group. Okay. Actually, CH3 group is called as a methyl group. Okay. Methane. What is the molecular formula of the methane? CH4. From methane, if you remove one hydrogen atom, that we can call as a methyl group. That we can call as a methyl group. For example, ethane. What is the molecular formula of the ethane?
CH6.
Ethane molecular formula,
C2H6.
C2H6. So from this one, if you remove one hydrogen atom, it is converted into C2H5. Na? C2H5 group is we can call as a ethyl group.
Ethyl group.
Okay. So similarly, propane also. From propane, if you remove the one hydrogen atom, that it becomes as a propyl group. Now you got the clarity? Methyl.
Yeah, sir.
So when you call as a methyl, when we call as a ethyl means here C2H5 group is called as a ethyl group and CH3 group is called as a methyl group. Okay. Now CH3 and C2H5 both are identical or different?
Different, sir.
Different totally. So whenever two different substituents are there, okay. So that time the names we are writing in alphabetical order. However, no, they write the names in alphabetical order in your school register.
Yeah,
All
sir.
your class names are in alphabetical order only na?
Yes.
So similarly, so when when two different alkyl groups are there means, okay, if the different alkyl groups are attached to the carbonyl system means their names we are writing in alphabetical order. Now you are telling that two different. One is the ethyl and another one is the methyl. So according to the alphabetical order, which it will come first? E or M?
Sir, I didn't get you. Could you repeat?
So according to the alphabetical order, which alkyl group comes first?
Ethyl group, sir.
Ethyl. Okay, so we can write as a ethyl. Next, what is another alkyl group it is there?
Methyl.
Ethyl, methyl, carbinol is the name. Now we got the clarity.
Yes, sir.
Now you got the clarity or not?
Yeah, sir, got it.
Okay, can I give one more example to you?
Yes, sir.
Okay. What is the name of the given compound?
Sir, phenyl, methyl. No, just a minute.
Hmm.
Ethyl, methyl, phenyl, carbinol.
Methyl, where it is there, ma?
Sir, C2H5.
C2H5 is the ethyl group. Now you said correct only. Ethyl group it is there. Next,
Uh,
benzene ring is called
Phenyl,
as phenyl. So correct only you said. Next is phenyl. Next,
carbinol.
that is only. So you added some methyl group. That's why I'm asking. Okay, carbinol,
It
ethyl
is got a bit
phenyl,
confused.
ethyl phenyl carbinol. Now we've got the clarity how to write the carbinol system means here. Okay.
Yeah, sir.
Today I had seen some previous year questions. There they had given the question based on this one, carbinol system. Because of everyone, they can write as IUPAC nomenclature and common names here. But alcohols only, they're having some separate nomenclature system. No other functional groups are not having. Even we didn't study about this kind of system in haloalkanes, haloarenes also, na? Okay, so only alcohols are having carbinol system. So now you've got the clarity about the nomenclature of the carbinol system. Ritu?
Yes, sir.
Okay. So then nomenclature system is finished one. Next we'll go for the isomerism. Okay, next we'll go for the isomerism. Okay, so we already studied about the isomerism. Alcohols are exhibits which kind of isomerism? Alcohol,
Alcohol, sir.
uh, alcohols are exhibits alcohols and phenols, both we can take here. So isomerism concept for we can apply for the both at a time only. Alcohols and phenols. Alcohols and phenols. Phenols are exhibits which type
Chain
of
and position, sir.
isomerism. Which type of isomerism? Okay, so first one you're telling that as a chain, right? So what is meant by the chain isomerism? What is meant by the chain isomerism?
It differs in the attachment of the chain, sir.
Okay, is any examples? A chain isomerism having same molecular formula but differ in the chain length here. Okay, so differ in their chain length is called here chain isomerism. What is the example means?
C4.
C5H12O. C5H12O. Okay, so first I'm writing as a structure like lining structure. I'm writing 1, 2, 3, 4, 5 OH. This we can call as a N-pentanol. N-pentanol. Sir, why we are calling as a N-pentanol means here all 5 carbon atoms are present in a straight line. So there is no branched chain. Are you going to find out any branched chains here? Do you find out any branched chains?
No, sir.
So all carbon atoms are present in a straight line means that we can call as a N-pentanol. Okay. And second one I'm writing as a isopentanol. Isopentanol. Sir, when we can call it as a isopentanol. Isopentanol. So when we can call as isopentanol means here, if the last but one carbon atom is attaches with the one methyl group. If the last but one carbon atom is attaches with the one methyl group, means that we can call as a iso. Okay. Sir, why we are calling as a pentanol means total number of carbon atoms in a compound is 5. Total number of carbon atoms in a compound is equal to 5. That's why we are calling as a isopentanol. And if you see the chain length, in the first one, you told that we have a 5 carbon atoms. 1, 2, 3, 4, 5 carbon atoms are there. But in the second one, once you checked out in root word, 1, 2, 3, 4 only. Okay. So how many carbon atoms are there in a root word in the second structure means here we have only 4 carbon atoms. And third one. So third one is we can write as a neopentanol. This we can write as here neopentanol. This we can write as a neopentanol. Sir, what is meant by the neopentanol means lost but one carbon atom is attaches with the 2 alkyl groups is called as a neopentanol. If the lost but one carbon atom is attaches with the 2 alkyl group means that with 2 methyl group means that we can call as a neo group. And total number of carbon atoms we are having 5. That's why we can call as a neopentanol. In a straight line, 1, 2, 3. In a straight line, we have only 3 carbon atoms. In a straight line, total how many carbon atoms are there? In a straight line, we have a 3 carbon atoms. Now, first one is having 5, second one is having 4, third one is having 3 only. But all are having same molecular formula. Okay, all are having same molecular formula but differ in their chain length. Okay, so whenever they're having the difference in the chain length, means that is only we can call as a chain isomerism. And all these 3 are we can call as a chain isomers. Okay, all these 3 are called as a chain isomers. Now you got the clarity. Anyone you having doubt? Ritu, do you have any doubt?
No, sir, got it.
Okay, next. What is the second isomerism means? As per you told that, so alcohols are they exhibit as a position isomerism also. Position isomerism. Also exhibit as here position isomerism. Okay, all these are the exhibit as here position isomerism. So what is position isomerism? Having same molecular formula but differ in their position of the functional group or substituent is called as a position isomerism, or that is also we can call as a positional isomerism also. Okay, compounds are having same molecular formula but differ in their position of the substituent or functional group is called as a positional isomerism. So what is the example for that one means? Let us see. So what's the difference it is there for the first structure and second structure, ma? What is the IUPAC name of the first structure? Ritu. What is the IUPAC name of the first structure?
Cis-dick pentanol.
No, ma, number of carbon atoms, you can check it out, ma. 1, 2, 3, 4 only, na, Ritu?
Yes.
4 means what is the root word?
Huge, sir.
Given compound is saturated or unsaturated?
Unsaturated.
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 It is saturated, ma, yeah. Unsaturated, when we can call as unsaturated means if the compound is having double bond or triple bond. That time only we can call as unsaturated. It is having only single bond. So then we can call as saturated. What is the suffix of the saturated hydrocarbons? Suffix of saturated hydrocarbons. N Ritu. Okay. What is the suffix of the double bond?
Yeah, so could you ask me?
Yeah. So what is the suffix of the double bond?
E-N-E.
What is the suffix of the triple bond? Suffix of triple bond. Y-N-E. Ine. Okay. And what is the second? What is the suffix of the alcoholic functional group?
O-H. O-L.
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 It's not the O-H. O-L.
Wow.
Okay. So now butanol. Which butanol means one butanol? Sir, why you wrote as a one butanol means OH group is attached to the first carbon atom. So that's why I wrote as here one butanol. Okay. And what is the IUPAC name of the second one? What is the IUPAC name of the second one?
Sir, 2-propanol.
Propanol or butanol? Number of carbon atoms once you checked out, Ritu? 1, 2,
3 na, sir.
4 number.
Yeah, sir. I didn't count the OH.
Okay. In line structure total we have 4 carbon atoms. So this we can call as a 2-butanol. Okay, first one is you wrote as a 1-butanol. Second one is we can write as here 2-butanol. Sir, what's the difference in these two means here? Both are having same molecular formula. Both are having here same molecular formula, but differ in the position of the OH group. Differ in the position of OH group. Now you got the clarity?
Yeah, sir. Got it.
Okay. No. Let's see. Next. So alcohols are exhibit as a functional isomerism. Functional isomerism. Functional isomerism. So what is meant the functional isomerism, Ritu? What is meant by the functional isomerism?
Same formulas but different functional groups.
Okay. So the compounds are having same molecular formula but differ in the functional groups. Now, first of all, we can check it out here. You're taking as a C2H5OH, ethanol, CH3 bond, CH2 bond, OH. This we can call as a ethanol. Actually, alcohols are converted into ethers. Alcohols are converted into the ether. So what is the general formula of the ethers? R bond, O bond, R. So what is the general formula of the ethers means here? R bond, O bond, R. Okay. So this one also how we are going to write? CH3 bond, O bond CH3. Okay. So ethanol is converted into dimethyl ether. Ethanol is converted into dimethyl ether. So that means alcoholic functional group is converted into the ether functional group. Okay. So when two compounds are having same molecular formula but differ in their functional group, means that we can call as a functional isomers. So now we got the clarity. Everywhere I am giving as a two examples here. Okay. One example only I give here. Here one more example we can write. Aromatic also we can write. Okay. So we are taking as a benzyl alcohol. So benzyl alcohol molecular formula is CH2OH. This we can call as a benzyl alcohol. Okay. And it is going to be converted into methyl phenyl ether. Methyl phenyl ether. What is the name of this one means here? Methyl phenyl ether. So it is converted into methyl phenyl ether. So now you got the clarity.
Yeah, sir. Got it.
But you told that something Ritu. Right. Next one. So what is the next one means here? Again, alcohols are they exhibit as a conformational isomerism also. Diols are exhibit conformational isomerism. So diols are exhibit as a conformational isomerism. So what is the best example means here? Ethylene glycol. Ethylene glycol. So what is the molecular formula of the ethylene glycol? CH2 bond OH bond CH2 bond OH. So ethylene glycol. Ethylene glycol is exhibit as a conformational isomerism. Ritu, do you have any idea about the conformational isomerism? Have you listened about the conformational isomerism? Have you listened about the conformational isomerism or not, ma? Actually, we'll get as a three
Yeah,
conformers.
so like it is a type of stereoisomers. I don't know much about it though.
Okay. Actually, alkanes are exhibited as a conformational isomerism. We have three conformational isomers. What are the three conformational isomers we are having means here? First, fully eclipsed. Second one is skew or Gachi form. Skew or GAUCH. Gachi form. After that, partially eclipsed. Okay, and staggered. So this also we can write as a anti-staggered. This also we can write as a anti-staggered. Sir, what is the structure of the fully eclipsed form means here? So we can write like this. So here this point is one carbon atom and the second circle part is another carbon atom. Second circle is here, another carbon atom. Actually, it has a three-dimensional structure. To make you understand, I'm going to write like this here. So because of one carbon atom is exactly behind another carbon atom here. Okay, it is not possible to see two carbon atoms at a time here. If you change some direction or something that we are able to see here. Okay, clear? And Gachi form. So what is the Gachi form is by rotating of the 60 degrees. By rotating of this in this one carbon we are placing as a constant. So let's consider it as a first carbon atom. Let's consider it as a second carbon atom. When the second carbon atom is rotated 60 degrees angle, you will get as a one more structure. So whenever you get as a one more structure means that we can call as a conformer. Here also OH and this H is comes outside this side and this is coming outside this way. So this we can call as a Q or Gachi form. Again, if you rotate one more 60 degrees, this one more 60 degrees, means we can write like this here. And in this one, OH, here also H and H. So here, whatever the OH it is there, again it comes here at this position. OH, here H, and OH plus we will get as a H here. Again, by rotating one more 60 degrees, okay, we'll get the structure is like this. Here also OH, here also H, here also H, here also OH, here also H, here also H is that. So this we can call as an anti-staggered form. So they're asking the stability. What is the question they're asking based on this one means here? So which one is more stable in diodes? Which one is the more stable means here? Skew form is more stable than anti-staggered. After that, partially eclipsed, and last one is eclipsed formation. eclipsed formation. Eclipsed is nothing but here fully eclipsed form is here. So which one is the least stable means here fully eclipsed form is least stable. Sir, why the skew form is more stable? Generally anti-stagger it has to be more stable na? Because of two OH groups are present exactly in opposite direction. Okay, but why we had taken as a skew form is more stable means skew form is it forms as an intramolecular hydrogen bonding. Due to the presence of the intramolecular hydrogen bonding, skew form is more stable than that of the anti-staggered. Now you got the clarity? Ritu?
Yes, sir, got it.
Okay, so once you go through this one more, then remaining part will continue in the next class. Okay?
Okay, sir.
Thank you, ma.
Thank you, sir.
Welcome.